All right, rectangular tabletop. This isn't anything different from Friday, right? 43 pounds per cubic foot. What am I giving you there? 43 pounds per cubic foot. That's my pounds per cubic foot. Mass, volume. What am I giving you? Density. Anytime I give you the density in a problem today, it's not a recommendation, it's a requirement. Circle it. All right, circle it. I didn't need you to circle it on Friday. Today I do, though. 43 pounds per cubic foot. Here's why. You were going to notice right away that the units in your density do not match the units of the figure we're talking about. The density is pounds per cubic foot. Read the dimensions of the tabletop. 8 feet, 3 feet, and then we got what? 1 inch. That's a problem. That is a problem. We cannot go any further in the problem unless the units in your density match the units on your figure. We cannot go any further in the problem until you change that 1 inch to feet. The units in your density have to match the units in your figure. Got me here? We can't move on. Don't do D over MV, nothing. Nothing. Can't do it. D equals M over V, sorry. So first thing we need to do, change the 1 inch to feet, and then we can move on. All right, how do I change 1 inch to feet? Well, if you know what to do with the 12, go. If not, what have I always said since the last couple units? 12 inches equals 1 foot. That is a conversion I will not give you. That's the one you got to know on your own. I think that's pretty common. I hope. I'm not going to give that to you. All right, over. My 1 is in inches, so it goes over inches. And you're looking for how many feet? And now we cross multiply. Again, I don't need to see this if you already know how to change 1 inch into 12 feet. 1 inch into feet. I don't need to see that. So go ahead, you cross multiply. I'm going to call on somebody now. Preferably as a fraction. I don't need this long decimal, especially if it repeats or goes on forever. I don't need that garbage. How many feet are in 1 inch as you cross multiply? Again, preferably in a fraction if your calculator gives it, which it probably will. Lauren, what do you got? 1/12. That's it. Here you go. 1/12 of a foot. So replace 1 inch with 1/12 of a foot. Now I can do the problem like I did Friday. But you can't move on unless your density units matches your figures units. All right, let's go. D equals M over V, just like we did on Friday. Density, you told me, was 43 they gave me. We're looking for the weight of the tabletop in pounds, so M again. And just like we did on Friday, right? We never had volume. We always had to calculate the volume. Okay, we always had to calculate the volume. Rectangular tabletop shouldn't be an issue in here. Rectangular tabletop. How do you calculate the volume of your rectangular tabletop? Shouldn't be an issue. Where are we going here, Drew?
8 times 3.
Thank you. 8 times 3. You better be using that 1/12 now, not the 1 inch. Bless you. And I don't need to call anybody here. That's 2 cubic feet, the volume of your tabletop. All right, plug that sucker in for the volume. And here we go. Find the mass. When you have the mass of the tabletop, please let me know when you cross multiply there. Bailey? 86. Yes. All right, everyone stop. We also have to get into this habit. First thing we check, does the density match our units? All right, they didn't, so I needed to change it before I did anything. At the end of the problem, you need to make sure your density matches what I'm asking for. All right, we took care of the feet, but it's also in pounds, right? What did I ask you to leave your answer in? Pounds. Okay, so we're done. Let's say I asked to leave your answer in tons. All right, I would need to convert that answer into tons at the end. Okay, it's going to go both ways. It may be different at the beginning. It might be different at the end, like it will be coming up. Any questions there? You cannot start a problem unless your density matches the units of your figure. All right, let's move on. I'm going skipping over to 3. Number 3, everyone. This is the last one I'm going to do with you today and let you work on your own. I'll let you guys read that bad boy through. There's a lot going on here. Snow cone, hemisphere and a cone. Gave you all the dimensions. All right, everyone read up on the snow cone before we go to the second part here. Here you go, density, circle it, circle it. Centimeters cubed. Look at the figure. What is your figure in? Centimeters. So we're okay. I don't need to change anything like I did the last problem. Is everyone all right on that? Sometimes I will, sometimes you won't. This is the toughest part about it. When do I do it? When do I don't? Centimeters, centimeters. We're good. We're all good. The problem's going to be, read on. See what they charge us for ice? They charge us per kilogram. But when I find the weight of the cone, look at your density. It's going to be in grams. Does everybody see that? We don't worry about that until the end. The only thing we change right away is the units on the figure, if I need to. And I don't here because they're both centimeters. All right, so let's go. D equals mass over volume. I need to find the mass of this snow cone. Help me find the mass, because that's what they charge me. They're going to charge me $3.83 for the mass. So we got to find the mass of the snow cones first. So 0.697 in for D. Mass, we'll figure out. And just like it's always been, calculate the volume of the snow cone. What's the figure on top again? Actually, just tell me both. This consists of 2 figures right now. The snow cone consists of 2 figures. We got to find the volume of. Name the 2 figures up here. Finley, name these 2 figures. It's a what and a what? Thank you. Great job. It's a cone plus a hemisphere. So most of you guys are already going there, which is great to see. You go look up the cone. 1/3 pi r squared times its height. And then you go, I don't have, sorry guys, I don't have hemisphere on there, but you do have a sphere, which you know you cut in half. So plus, I don't cut it in, I just put the 1/2 next to it. So a hemisphere, 4/3 pi r cubed. Everything is there for you to substitute in. My worry is what you type on your darn calculator to get the volume here. And make sure that 8.3 is the diameter. So 8.3 should not be found anywhere in your substitution here. Should have 4.15 in instead. And please keep accepting all the decimals all the way through here. This is not even close to our final answer. Again, even if you substitute in something right, be careful on your calculator. Or you can leave it in terms of pi. Write out everything or leave it in terms of pi. Your call. But I'm getting 333 and a little bit more for the volume here. Make sure we can get that. A couple people in my first period class, they added this 10.2 instead of multiplying. Be careful what you type. Be careful what you type. Before I move on, anybody need calculator help here? Make sure you're squaring the cone, but cubing the radius on this hemisphere. There's always a little something here. Make sure you have 1/2 and 4/3 on the hemisphere. Make sure you have 1/3 only on the cone. There's a lot going on here. The substitution's easy. The calculator part's the harder part, probably. Okay, I'm going to move on. We all right here? Getting it on your calculator. All right, there you go. Substitute in that for the volume. Substitute that in for the volume. Cross multiply. Find the mass of one snow cone now. Go ahead, cross multiply it. Find the mass of one snow cone. Keep writing out those decimals or leave it in terms of pi. I don't know if your calculator's doing that. Questions on the mass up here. All right, what is the units on the mass now? Look back at your density because this is where we're going to have to do this serious part here. What is the units on my mass? Look back at your density. It'll tell you what the units are. What's my units on my mass here? Tess? What was the density in?
Grams per cent.
Okay, so it's grams. All right, everyone see that? It's grams because that's what the density was in, so that's what my answer is going to be in. Keep reading the problem though, right? They charge me $3.83 per kilogram. So I'm not ready to use that 383 because my answer is still in grams. So I need to convert it to kilograms. Everyone good so far? Got to convert it to kilograms. All right, so step 2. Please take a look at your formula sheet for me right now. Look at your formula sheet so I can tell you guys something pretty important here. Look at your formula sheet. Do you see up above, you have a whole slew of conversions, right? Now you'll notice if you keep searching, you do not have grams and kilograms on there, which means if it's not on the formula sheet, I will provide it to you in the problem. All right, come quiz test day. All right, so there'll probably be something like this. It's not on your formula sheet, so I'll probably have something that looks like this. 1 kilogram equals 1,000 grams on there. The only thing you are responsible for conversions, 12 inches equals 1 foot. That's on you. Everything else is on the formula sheet, or I will give it to you. Okay? So let's convert this right now. Let's convert this number of grams into kilograms. We're going to set up a proportion. You have half the proportion already in the conversion. 1 kilogram equals 1,000 grams over. Now put your grams underneath grams. Once again, I do not require the proportion. If you guys already know what to do with the 1,000, go. All right, let's find out how many kilograms there are. Cross multiply, you guys see I end up dividing by 1,000, right? When you solve this proportion, you end up dividing by 1,000. So less than 1. This is how many kilograms a snow cone weighs. All right, let's keep going because we're only about halfway through this problem. They're going to charge me $3.83 per kilogram. What do I do with that $3.83 and the number of kilograms I have? Well, if you don't know, we set up a proportion again, right? If you don't know, set up a proportion. I don't want to make it an excuse that you're going to guess. So if you don't know what to do with the 383 and this number of kilograms we found, all right, ready? 1 kilogram, they charge me $3.83. I'm not going to bother rewriting that, so I'll do the old arrow trick there. That's how many kilograms I have. How much are they going to charge me? I don't even know the answer to this one. Times. Yep. If you want to write it all out, you can. If some of you guys rounded to what, about 89 cents? That's how much they're going to charge me. I'll just keep writing it out here. But 89 cents isn't my answer, though. There's one piece I haven't even spoken about yet. That's 89 cents for a snow cone, right? They're going to charge me 89 cents for the ice for a snow cone, but what are we looking for? 50 of them. All right, so we do have a fourth step, which is, all right, take 50 snow cones now, and it's about 89 cents a snow cone. Let's multiply those two bad boys together. Yep. Now we do have to round anytime, even if there's no rounding directions, it is money. So we always go near a cent, or AKA hundredth. So they're going to charge me what, $44.53 for the ice. Before we move on here, heads up. I don't know if some of you are thinking of it because I know I got some clever kids in here. This 50, did I have to multiply it at the end? No, I could have multiplied it up here. Like how many grams are in 50 snow cones and went from there. How many kilograms are in 50 snow cones? All right, did I have to wait to the end? No. So you could have multiplied by 50 right here after you found the mass or after you found the kilograms. You could have multiplied by 50 at any point in the problem there. All right, any questions? Okay, Chromebooks out. There, you know where the answer key is. I highly recommend just not copying the work so your paper looks filled up. Call me over if you're stuck somewhere. These are not going to be easy. Circle your density every time. Circle your density. Does my figure have the same units? You guys have 5 more problems there. Yep. Maybe I'll put that in right now. What's up, Lon? Yeah, go ahead. Hey, look, move around. I don't care, guys. Move around. Look whoever you want. Work with whoever you want to work with. Just don't copy the answer key. It's not going to help you. Call me over if you're getting stuck. And that's a wrap. Geometry AB. Check your units. You're gonna have to change something, whether it's at the beginning of the problem or for your mass. Guarantee it with these problems, you will always have to change something now. I'm gonna pass that back Friday. Surface area quiz. Sorry, go ahead.
If I do it like this, so if I do it with how many like into the first news is that fine?
Yeah, no issues there. What's that?
You did it at first. You got
Yeah. Yeah, that's fine. Just like we did with this, the 50. You can do it at the beginning or at the end. Doesn't matter. Yep. Got some stud problems there.